Hello, dear friends. Uh, Today, let's talk about a bit on this uh, statistical concept of 95% confidence interval, which is denoted as CI, and another term which is most people might not be knowing, that is a 95% prediction interval, or denoted as PI. Now, 95% confidence interval is pretty much used in all the kinds of statistical phenomena in all kind of research, be it a primary research, it could be it could be a clinical trial, or even systematic review. So anywhere you are providing some p-value in research, so you give the 95% confidence interval of that pi, and I'm coming to what is the meaning of that 95% interval. But in addition to this 95% confidence interval, there is another interval which is a 95% prediction interval. And this prediction interval is pretty much used in your meta-analysis. When we do a meta-analysis of systematic reviews, and you will not see this prediction interval in every meta-analysis, but in some good meta-analysis, you will see that the values of this 95% prediction interval, they are pretty much same and pretty much different at a time. And let's discuss how. Now, this video is obviously for those people who know about some basic statistics, and especially those for PI is concerned, those people who know about the meta-analysis concepts. So, first let's discuss the what 95% confidence interval is. So whenever we do a study, and obviously in a study we come across certain results, and I will show you it in a forest plot. Actually, what forest plot is? Forest plot is actually created in meta-analysis when we pool multiple studies for any single outcome. Say for example, we are doing a systematic review of say for example 10 studies. We've taken the 10 already published research on the systematic reviews or other kind of studies. It could be clinical trials, it could be your cross-sectional studies and observational, though usually the meta-analysis are done with clinical trials, but you can do with other as well. So say for example you are doing an study of that, the study is about a drug, sorry, don't mind my writing. We have got a drug X and we have got a drug Y. So these could be any drugs, and we are looking at the published clinical trials. Many will try to search as many clinical trials on that topic or that study. So for example, we are going to PubMed and other databases. We ultimately collected 10 studies. That 10 studies were performed in different regions of the country, and all 10 were looking at this comparison that is a drug X and drug Y. That drug X in comparison to drug Y, and these both drugs, what they are doing, they are actually increasing your hemoglobins. That means these drugs, both drugs are used in anemia, and we are seeing if that drug X is superior to drug Y or not. And in all the results, all the, say for example, we collected 10 clinical trials, and that clinical trials actually did a comparison between this drug X and Y, that which is increasing the hemoglobin more in patients with anemia. So this is a theoretical example. So say for example, when we collected the results from each of these 10 studies, and say for example study 1, it could be result 1, and study it could be result 2, then the results of third study, ultimately we combined the results of all those 10 studies. And when we combine the results of multiple studies to get a final full result in meta-analysis, now this process is called as the pooling. What this call as? We called as the pooling. You can collect 5 studies, 10 studies, 20, 40 studies, whatever the studies are available on that certain problem, and you collect the results from all those studies on certain parameter, and that process is called as the pooling. And the final result that we got, like here I have denoted this N, that is known as the effect size. We called that final result as a effect size. Those who knowing about the meta-analysis, they know what this effect size means. So effect size is actually a number or result. And say for example, in this example, what the results, combined result or pooling results of that study showed us. And that shows that, let me remove all this for you and we can focus onto this. So we combine the results of all 10 studies and we came across a result. So here it is. So we were looking at this drug X versus this drug Y. So what is the how much hemoglobin these both drugs are increasing. So ultimately we collected the results of 10 studies and combined the result of all 10 studies to get a final result, say for example n, whatever you call it. And for example, we found that this drug X it increased the hemoglobin. This drug X increases the hemoglobin that is 2 point. This drug X actually increase the hemoglobin 2.8. Sorry if you don't mind my writing. So this drug X actually increased the hemoglobin 2.8 milligrams, okay, more than this drug Y. So ultimately when we combine the pool data from 10 studies, and ultimately the all combined result was that this drug X increases the hemoglobin. Drug X increases the hemoglobin 2.8 milligram per deciliter. So this 2.8 is actually we call that is a mean effect size. I hope that people know what is the meaning of mean. Means that in simple terms the average of all. We collected the mean rise of hemoglobin with the drug X in all those 10 studies and combined then the combined mean of all those 10 studies was 2.8. So this 2.8 is a mean increase in hemoglobin by drug X comparison to Y in those clinical trials. But whenever you will give any mean value, any median value, or whatever value you give, that value will be accompanied by this 95% confidence interval. So you will give this 95% confidence interval and say for example this result with the mean of 2.8, we have got a confidence interval of say for example we got a confidence interval of 0.4 to 3.5. Now this is 0.4 to 3.5 is your confidence interval and your mean rise was 2.8. okay, we understand that mean rise was 2.8, but what does this 95% confidence interval of 0.4 to 3.5 mean? Now confidence interval means actually this confidence interval gives us the precision. It gives us the precision of this mean number, that what is the how precise this value is, that what we got from the results of those 10 studies, whatever that result is, it could be anything. So how much precise this result is, because we are not only concerning the numbers, especially in health, we also need that how much significant that number is. We are going to get some results anyhow in any studies that could be significant and insignificant, that we know by the p-value. If p-value is less than 0.05, then it's significant. But the main thing that actually tells you the significance of that p-value or the significance of that mean value is this confidence interval. So this confidence interval is actually the precision. It will tell you the precision of this mean value of this particular study only. Say for example, this is the value of your study and this is the confidence interval that applies to only this mean value of your study. So it tells how precise, how good this is. So what does this mean? Now this actually means, first, this is the mean value that are found in your meta-analysis, and that you did with these 10 studies, but these 10 studies say could have been from some 5,000 patients, some 500 patients, some 10,000 patients, 50,000 patients, 2 lakh patients. You must have gone through different studies that sample size varies. Whatever the value is, ultimately when we are talking about results, we actually have to generalize those results to the whole world population, or sometimes to a certain large population. And whatever the population is, whether it's on the world level or in a certain region, that population is going to be in tens of millions, or sometimes there are billions of people in the world. So how can you generalize that it applies to all? This will tell you that how precise. Confidence interval is actually not the value of your study. Confidence interval is mathematically calculated. That will show you that what will be the true results, what will be the results of such studies, of such parameters, when you are applying such kind of, say for example, these drugs in general population in real world. What will be your results in the true results in your true population? So this is actually will show you, confidence interval will show you that what will be the results of such interventions in true population. That is in true population. This is the meaning of confidence interval, that whatever you found in your study as a mean, as a median, or as a number of value, this confidence interval tell you that this will be the result in true population. And usually confidence interval is given in a range, that it will give you a range of certain values, that your true mean. So this is the mean was 2.8 in our study, but it says that theoretically, I'm giving an example, that this with this confidence interval, your true population will, the results of such intervention, we are giving this drug X in population to patients, the true result will vary from 0.4 to 3.5 milligram. So if this confidence interval is narrow, then that shows more precision. Say for example, mean is 2.8, and if our confidence interval is from 2 to 3.2, so and another confidence interval is from like this 0.5 to 3.4. Now in which say this we have got a 3.5 on higher side, that's close to 2.8, not too big, but 0.4 is far below this 2.8. And if for example we have got another confidence interval between, just say for example 2.4 to 3.4, then 2.4 and 3.4 both are the values close to this 2.8, and that if we get such a confidence interval, then that means that that is a better confidence interval as compared to this 0.4 to 3.5, which has a big difference. That is we called as this as a wide confidence interval. Another, so I talked about another confidence interval from 2.4 to say for example 3.4. You can see that this 2.4 to 3 is a, we call it a narrow confidence interval, because these values on both sides, on lower side as well as we call it the lower bound and upper bound, it's close to this 2.8, while this is a quite wide. This ranges from 0.4 to 3.5. That means in true population, when you will give this drug, you will get, in some people you will get as little rise in hemoglobin as this 0.4, and as you know, as greater rise in hemoglobin as 3.5. But if you get this confidence interval between 2.4 to 3.4, so this is quite, you know, closer to this. That means if you are giving the minimum rise, that is also 2.4. If you are giving maximum, that is also 3.4. So both are quite significant. That depends on what, in terms of when we are talking of hemoglobin, then hemoglobin of 2.5 to 3.4 rise is quite significant. But here this 3.5 is significant, but lower bound is 0.4. That 0.4 is not a big difference, but 3.5 is a big difference. So if your confidence interval is wider, that's less precise, will be your mean. If your confidence interval is narrow, your mean will be more precise. And this is the meaning of confidence interval, that confidence interval will give you the value of true population. This is the value of your study, but this will be the value of range of value of in your true population. Now this is the meaning of confidence interval. Like here in this study, this is a forest plot of a meta-analysis in which we combine the results of this 1, 2, 3, 4, 5, 6. So these are 6 studies, and these are the results of certain parameter of these 6 studies. And you see that these are the mean values of these studies. And here is this is the 95% confidence interval of each mean. You can see this one is one mean confidence interval, mean other, and we, after combining all these studies, we get this is the p-value that shows that it's insignificant. This is the combined value of all studies, which is called as a pooled effect size, and this is the confidence interval. So the combined result was 0.54 and your confidence interval was 0.43 to 0.64. Now seen here, we got the combined result of mean was 0.54 and our confidence interval was 0.4 to 0.64. So this is even on lower side and upper side, it's consistent with this results, that it is showing that some parameter is decreasing with an intervention, and its confidence interval on both sides is also showing that it is decreasing. So it's very we can call it a narrow confidence interval. That is why this result is quite good precised. Okay, here is this. You will have got this 1, this 2, this 3, 4, 5. These are the results of different studies, but this is your combined effect size. This blue diamond is a quite wide diamond because the results and the values are quite wide, but this is your pooled effect. And here we got that confidence interval was 0.43 to 0.64. so that confidence interval lies here, 0.43 to somewhere 0.64. now this is the range of confidence interval in this study. That means this will be the range of values in true population. But here is another term which is called as the prediction interval. Now what prediction interval is? You can see that this value here 0.2, and you are getting another value I will show you here, 0.98. you can see the both extremes. This is the confidence interval from 0.43 to 0.64. like here, this was your confidence interval of this meta-analysis of 6 studies. We just talked about this. But what is this extreme of minimum to this extreme of maximum? See, the minimum extreme is 0.2. it's quite low, it's very low. Another extreme 0.98. both are very small results, but talking in this particular study, the results as in this particular study from 0.2 and 0.98 are quite far from each other. There's a very different meaning of 0.2 and a very different meaning of 0.2. It could be like just we'll get this result. Say for example, in this result where we had this confidence interval of 0.4 to 3.5, but for example, if I get a value of minus, say simple, I'm doing it simple, minus 1 to 4. I'm taking the example of, say for example, this study here we have got this 2.8 and we have got this 0.4. say for example, we are getting 0.4 to 3.5. that would have been our confidence interval. But here from this minus 1 to this 4, say for example, like here we have 0.2 to 0.98. what is this? Now this value is called as the prediction interval. This value, like here from 0.2 to 0.98, I would have write it like this, 0.2 to 0.98. so sorry for my bad writing, and I'm writing it on. So this is 95% prediction interval, and you can see that confidence interval here is different. It's 0.43 to 0.64, but confidence interval is even more wider. It's 0.2 to 0.98, quite wider than this 95% confidence interval. It's like here, this is your confidence interval, but this is 0.2 to 0.98. this 0.2 to 0.98 is actually your prediction interval. What does this mean? We talked about confidence interval means the range of value in the true population. But this prediction interval, now this prediction interval you are going to find wider. Why? Because this prediction interval gives you the range of values that will be found in the potential future studies. What does that mean? That means that if you are doing the similar study and some other people are doing the similar study in some different population in the future, like after your study 6 months, 1 year, or it could be many studies coming up in future with the same intervention and looking at the same. So what will be the expected values, what will be the range of expected values on those studies, and that estimation of results in the future studies is known as prediction interval. So this prediction interval will tell you that what will be the results of such intervention in future studies. So you say that it's quite wide. In this particular study, the confidence interval is quite narrow, but the prediction interval of the same study is very wide. It's from 0.2, that means very low, to 0.98, it's very less. Why I'm asking this low and why this less, and that you actually it's a talk of concept of these terms which I'm not going in detail. So those who know about these confidence intervals and meaning of these values, they know what I'm saying, that why this is low, why this is not much low. So this is wide. So it shows that in future studies, whoever conducts such studies in future, the results are going to be more variable. It shows actually the inter-study variability. That means variability between different studies. Like you did the one, it could be some previous studies someone is doing in the future. So what will be the variability, inter-study variability, between study variability? So again, that it is too wide. If that PI is too wide, that means showing is that is a variability of results. If that would have been quite narrow, and that means that the future studies are also going to be quite precise. So what does this mean? This confidence interval is give you the precision or accuracy of the results of your study, but this prediction interval will give you the idea of what may happen in the future study. So this is actually applies to clinical practice or the practical implication in real world. Here, and again I'm going back to this, my Word document says a 95% confidence interval for a effectiveness of a drug that reduces the blood pressure. The one drug that reduces the blood pressure, and its confidence interval is this from -10 to -5. That means this is a confidence interval that drug reduce the blood pressure in some people from -10 and some up to -5. This was the confidence interval, and this actually suggests that true average reduction in BP is likely between. So whatever the result was, the confidence interval that this will be your true average reduction with that drug in your population. But PI is -15 to -10. This prediction interval of the same drug is between -15 to -2. That it could be in some people it will reduce the blood pressure up to -15 mm, and in some just -2. So this PI shows that the future studies will usually observe such results, and this is indicating more variability in your real world as compared to this study, that in real world this drug is going to have more variability. So here, what is the meaning? CI focuses on the summary estimates, so focuses on precision of your estimate of your study, whereas a PI addresses actually the real world variability, that what going to the variability in real world when the different studies are going to be done in future in different populations. So this is the meaning of your confidence interval. I hope that concept will have been quite clear now about this. If you don't know about the prediction intervals, just go and read more about prediction interval, and if you're planning any meta-analysis or doing, try to include this prediction interval as well into your results. Thank you.